In this video, we're talking about finding equations of tangent lines to particular curves. So the one thing to keep in mind here is that there's a big difference between finding the slope of a tangent line in the equation of a tangent line, right? So you have to be very careful about the wording. So what we're going to be doing in this video is finding equations of tangent lines, which is one step further than just calculating the slope, which we've been doing a lot in class. So for the first one, we're going to say find the equation of the tangent line to the curve y equals x squared plus 1 at the point 2, 5. So we want the equation of the tangent line to be of the form y equals mx plus b. And it's the way that we're going to do this is that we are going to, first, we have to remember, well, what is the m? Right? Well, the m is the slope. And how do we calculate the slope of a tangent line? Right, we use the derivative of the original curve. Right, so the derivative at that point gives us the slope of the tangent line, not the equation, but the slope. So what we need to do is we have to take the derivative of this function y and then use that to figure out the slope of the tangent line. And then we're going to use the point slope formula in order to figure out the rest of the equation. So to start off, right, so we know that, so we have the curve y is equal to x squared plus 1, right? And then so the derivative of y with respect to x is the derivative of x squared plus 1. And then we know from before that this is just 2x, just the simple derivative of a polynomial. Okay, so that's the derivative. And the slope, so the slope, I'm going to underline this, the slope of the tangent line. The slope of the tangent line at the point 2, 5 is given by the derivative evaluated at that point. So it's the derivative evaluated at the point where x is equal to 2. And that is equal to just 2 times 2, so just putting x in, putting 2 in for x, and that's 4. So the slope of our tangent line at that point is going to be 4. So therefore, m is equal to 4 in our equation. Okay, so next what we're going to do is we're going to use the point slope formula with the slope we just calculated and the point we were given in order to get the rest of the equation. So next, since we have m equals 4, and we were given the point 2, 5, right, we can use this. So we can use the point slope formula. Spelled slope wrong. Point slope. Formula. Y minus y naught is equal to m times x minus x naught. So here, so the point x naught y naught is just the one that we're given, 2, 5, right? And then the m, we know, is 4. Okay, so when we plug this stuff into the equation, so y minus y naught equals m times x minus x naught. So the y naught here is 5, the x naught is 2, and the m is 4. So we have y minus 5 is equal to 4 times x minus 2. So now if we just distribute the 4 in, so we can say this is y minus 5 is equal to 4x minus 8, and then just bring the 5 over. So now we've got y is equal to 4x minus 8 plus 5, and then we've got, so just simplifying this, the equation of the tangent line is y is equal to 4x minus 3. Okay, so the idea behind this, if you want to figure out the equation of the tangent line, the first thing you want to do is you want to find the slope of the line. And this is the same thing we've been doing throughout the whole class. The slope of the tangent line is given by the derivative at that point. So we calculate the derivative, stick in the x value, and that'll spit out the slope. Then we can use the point slope formula with the point we were given and throw it into the point slope formula, and then just put it in the form y equals mx plus b. And then that's this one right here. So after you simplify everything, that's what you get. So in this case, the equation of the tangent line at that point is given by 4x minus 3. In this next problem, we're looking for the equation of the tangent line to the curve y equals x times e to the x at the point 0, 0, so just at the origin. So just like the last problem, it's the exact same steps. The only thing that really changes about these problems is the function that you're using to draw the tangent line to and the point that you're drawing it at. Those are the only two things that change. But the process is exactly the same. So we remember, so what we're going to do is we want the tangent line, it's going to be of the form y equals mx plus b. Right? So let's see here. So we want the tangent line equation will be of the form y equals mx plus b. And again, the m means slope, and the b is the y-intercept, but we're not really looking at that here. The thing is, if you notice that since we're drawing the tangent line at the point 0, 0, you can actually tell from this problem that the y-intercept is actually at 0, 0, because that's where the function is crossing the y-axis. But we're not going to worry about noticing that here. We're just going to do it like we normally did. But if you happen to notice that, feel free to use it. Okay, so anyway, so we've got y equals mx plus b. So just like last time, to find the slope, we need the derivative. So we have y is equal to x times e to the x. And the derivative of this function is going to give us the ability to calculate the slope. Right? So we've got dy by dx. So this is the derivative with respect to x of x times e to the x. And notice that these are just two functions being multiplied together, so x and e to the x, so we can use the product rule. So by the product rule, so we can say it's first times the derivative of the second plus second times the derivative of the first. Okay, so we know that the derivative of e to the x is just itself, so we've got x times e to the x, and the derivative of x is just 1, so then we've just got e to the x times 1. So there's an e to the x in both terms, so we can factor that out. So we've got e to the x times x plus 1. So that's our derivative. And the slope of the tangent line at the point 0, 0 is going to be given by that derivative evaluated at the point where x equals 0. So let's see here. So the slope, I'm going to highlight this. So the slope, we're not getting the equation of the tangent line yet. We're only getting the slope. So the slope of the tangent line at the point 0, 0 is given by the derivative evaluated at the point where x equals 0. So then plugging 0 in, we got e to the 0 times 0 plus 1. Remember, e to the 0 is 1. 1, 0 plus 1. So this is just 1. So that's the slope of our tangent line is 1 at the point 0, 0. So now we use the point slope formula again. We use point slope y minus y naught equals m times x minus x naught to figure out the rest of the equation of the tangent line. So here in this case, right, our x naught and y naught is just 0, 0. It's the point that's given. and the m is 1. Okay, so we just plug all that into the equation. So we've got y minus 0 is equal to 1 times x minus 0. Okay, so this can just be simply written as y equals x, right? And so that's the equation of the tangent line at that point. And again, just so you can see it, notice that this is of the form y equals mx plus b, where m is 1 and b is 0. Right? So that kind of goes along with what we were talking about at the beginning here, right? Where we notice just from this point at just it being at 0, 0, that would have given us the actual y-intercept, but you don't need to know that information just from that to figure out the equation of the tangent line. You can always follow this process and get the same thing. So that is the equation of the tangent line that we want. All right, for the last problem, again, all of these are pretty much the same. The only thing that changes is the equation of the only thing that changes is the curve and the point, right? So same process for everything. So again, we want the equation of the tangent line. So we want it of the form y equals mx plus b. So remember to find the m, we're going to need the dy by dx evaluated at, now in this case, we're going to want it at 0 because that's the x value that we're looking for. And the b will come out of the point slope formula. So the first thing we need is the derivative of the function we were given. So we've got y is equal to e to the x over x minus 1. And the derivative of this, so dy by dx, so it's the derivative of e to the x over x minus 1. And then we remember that if we have e to a function, the derivative of that thing is just the same thing, e to the x over x minus 1, but then you multiply by the derivative of the stuff that's in the top there, the stuff that's in the exponent. Okay, now this is just two functions, one being divided by another. So we can use the quotient rule, right? So if we use the quotient rule, so this stays the same. The quotient rule says low times the derivative of the high thing minus high thing times the derivative of the low thing, all divided by the square of the denominator. Okay, so we can simplify this a little bit, right? So to do that, well, we know that, so we got x minus 1. The derivative that we're looking at here, so the derivative of x with respect to x is just 1, so there's a 1 there. Then we got minus x times, and then the derivative here of just x minus 1 is still 1. Right, so we've got 1. And then everything on the bottom stays the same. Okay, so then we can simplify this a little bit. X minus 1, all times, so we've got x minus 1 minus x all over x minus 1 squared. And then a neat little thing happens here where these x's cancel off because you have a positive x on the left and a negative x on the right, so they go away. And then what you're left with is this e to the x over x minus 1 times minus 1 over x minus 1 squared. Okay, so that's the derivative. Now, what we want is we want to evaluate the derivative where x is equal to 0, I believe it was. Yes, 0. Right, so the slope of the tangent line, again, so the slope, not the equation, but the slope of the tangent line. At the point zero, 1 is given by evaluating the derivative where x equals 0. So when we do that, we're going to stick everything in. So this is e to the 0 over 0 minus 1, all times minus 1 divided by 0 minus 1 squared. Okay, so got a lot of minus signs floating around here, so let's see what happens. So we've got e, so now 0 divided by 0 minus 1 is just 0 divided by minus 1, which is just 0. Then we've got minus 1 divided by minus 1 squared, so that minus 1 squared becomes a plus 1 in the bottom. And then e to the 0 is just 1, right? So we have 1 times negative 1 over 1, which is just negative 1. So that's the slope of our tangent line. So therefore, m equals negative 1. Okay, so then for the next part, it's, again, identical to what we've been doing before. We're going to use the point slope formula, y minus y naught equals m times x minus x naught, right? And here the point we were given, so x naught, y naught, is the point 0, 1. So we literally just plug in this point and the fact that we know that m is equal to negative 1. So we've got y minus 1 equals negative 1 times x minus 0. Okay, so now if we do a little simplification here, so this is y minus 1 equals negative x, right? And then we can bring the 1 over. So we get y is equal to minus x plus 1. And that is the equation of the tangent line for e to the x over x minus 1 at the point 0, 1. So again, just go back and look through this video again and just notice that the process for doing this is the same every single time. The first thing you want to do is you want to find the derivative of the function you were given, then evaluate the derivative at the point you were given, because that'll give you the slope of the tangent line. Then you can use the point you were given, throw it into the point slope formula along with the slope you found, and then you just solve for y, and you end up getting the equation of the tangent line in the form y equals mx plus b. And this works the same way every single time. Okay, so that's the end of this video, and yeah, so that's it.